Howdy students, welcome to your first lesson of R. This is going to be your first time using R, and before we get started you should have downloaded lesson 1 and R lesson 1 homework. This is going to be your homework assignment, and this is going to be what we call the script of the lesson. So go ahead and open up this lesson 1, click on that as you see what I just did, and what automatically happened was that R opened up by itself, and there's two things that just came up on your window. This is the script, this is what I wrote, this is essentially the code. I'm going to go over that in just a second. And back here is what we call the R console, and this is where you're going to do all your writing. Write stuff down there and hit enter, and it's going to yell at me right now because it doesn't know what I'm doing. But don't worry, we'll find that out in a minute. So the way I had organized this lesson and all of these lessons is you're going to get what's called R script. I'm going to write out these scripts, and this is going to be your lesson. Now you notice all these pound symbols, or as you folks call it nowadays, hashtags. And when I write a hashtag in R, well, let's put it this way. What this whole script is essentially like a blank text document. So there's nothing fancy going on here. But what we're going to be doing is copying and pasting things into R. Anytime we copy and paste something into the console and we have a hashtag symbol in front of it, it just ignores it. So if you just saw nothing happened, it didn't. When I say nothing happened, there was no error code like we had here, and we see that we moved on to the next line. Why? Because it ignores anything after a hashtag symbol. So the reason why there's all these pound symbol. So the reason why there's all these pound symbols is if you happen to accidentally copy and paste in all these words, it's going to ignore them, and it's just going to look at something like the code. We'll get there in just a second. So the goal of this lesson is to learn how to use R just as a simple calculator. Not that it's the best thing in the world to do that with, but we can use R as a calculator, and a lot of times it's easy because for me, I do this a lot on my computer because it's open and it's easier than getting the calculator out from the console. So we're going to learn how to use R as a calculator. You're going to learn how to use R to add, subtract, multiply, and divide. We're going to look at correct syntax for R, including little tricks and specifically error codes. And then we're also going to look at some common mathematical function beyond just multiplying, subtracting, and dividing. Some of them which may be useful for you, some of them which may not. So let's get into it. So let's start out learning how to just use R as a simple calculator. So the symbols for adding and subtracting, adding is our plus sign, and it should be on your keypad Shift and the equal sign, 2 over from the number 0. The minus sign, which is right next to the number 0. Our multiply function is going to be the star symbol at Shift 8. So if you hit Shift 8, when we get there in a minute, that is going to be our multiply symbol. And our divide is going to be the backslash, that is the one that shares its space on the keyboard with the question mark sign. So let's try some basic operations. And the way I have set these lessons up is anything without a hashtag after it is code. So let's try doing 1 plus 1. So what I actually ask you to do, or you could type this in by your hand, but just highlight, copy, I use Command C. And then let's go into the console. Let's go into a blank spot here in the console and paste it, Command V. And we're going to do 1 plus 1. We're entering 1 plus 1 in the console. And the answer it spits back is 2. Now you might wonder what's this little 1 in the bracket doing there. This is gonna be more useful when we have long lists of numbers, but what it's telling me is the first element, the first entry of my answer in this case is 2. Well, you're only going to get one answer when you add, subtract, multiply, so for this whole lesson we'll probably just be seeing that one, but we'll see later in the line that that is actually very useful. So let's try 1 minus 1. Hopefully that's 0. And instead of copying and pasting this one, maybe just try to physically enter this on your keypad. So 1 minus 1, we're all done. You hit enter. Phew, 0. Thank you, R. You know how to do some basic math. First grade, here we come. How about 1 times 1? So again, this is the Shift 8 key to do, to multiply. So let's just try that by hand right now. Instead of copying and pasting, let's do 1, Shift 8 times 1. And last time I checked, indeed, 1 times 1 is 1. Okay, let's get something maybe a little more unique. How about 1 divided by 2? 1 backslash 2. And again, or is that a forward slash? Excuse me, that is a forward slash. So we'll hit 1 divided by 2 equals 0.5, precisely what we were looking for, 1/2, 0.5. So to make more complex calculations, R uses the order of operations that you may have learned way back in the days. PEMDAS, please excuse my dear Aunt Sally. I've heard a few other words for this, or acronyms for this. I'm not sure what they are, but the idea is we do what's in the parentheses first, then we exponentiate, we do exponents, then we multiply, divide, add, and subtract. So if I were to do something basic like this, 1 plus 1 divided by 2, PEMDAS says that I should first divide and then add. So this should get me 1.5 or 1.5 if we did everything correctly. Yay. Notice how that's different than if I do something like 1. If I do the 1 plus 1, I could put this in a set of parentheses. 1 plus 1 divided by 2. Now it should do what's in the parentheses first, which 1 plus 1 is 2. 2 divided by 2 now is 1. So the order of operations is very important. How about something a little crazier? Try copying and pasting this line here. So we got 2 divided by 2 plus 2 times 2 minus 4 divided by 2. So if this does the operations correctly, it should divide it. So 2 divided by 2 should be 1. Then it should multiply. 2 times 2 is 4. And then it should subtract this. 4 divided by 2 is 2. So it should be 1 plus 4 minus 2. I'm already lost, but I think that should be, what do we say? Right, you got it. There it is, 3. Good job. Again, we can use this parentheses like I did before to organize an equation, but you do have to be careful. The reason why is when it sees parentheses, it's actually going to kind of assume that there's a function going on. Like, you remember something like f of x back from Algebra 2 or algebra? We say f of x, like f parentheses of x, we're saying this function of whatever's inside the domain, which is x. So we need to be careful here. So for example, if I want to do something like 3 times 6 minus 3, and just to show you this hashtag here, I can copy and paste with those pound symbols slash hashtags, and it's going to ignore all of this. So it's just going to do this operation, but we get an error. Why do we get an error? Because with this little 3 parentheses, it says attempt to apply a non-function. It's actually thinking that there's some function called 3, and we're going to do 3 of 6 minus 3, but it doesn't know what this function is. So it's giving us an error code. So to fix this, what I can do is this is a little trick I'm going to use. I'll re-explain this in a little bit. But if I hit the up arrow, if I hit it once, I actually get the last line of code that I just used. And if I hit the up arrow again, it'll give me, wait a minute, there it goes, up arrow. If I hit the up arrow again, it'll get me the code that I used before that, and before that, and before that, and before that, before that, before that. And I could even go down, and I'm going back down now and hitting the down arrow. And these are really useful because it's a good way to come back in, and maybe you did get an error on a piece of code. Just hit the up button and you don't have to retype, you don't have to copy and paste anything. So if my goal of this problem was to multiply 3 times 6 minus 3, what I need in here is a shift 8, I need a star. And once I do this, it's going to do exactly what I thought it would do. 3 times 6 minus 3, what's in the parentheses? 6 minus 3 is 3. 3 times 3 is 9. So this, again, this is a really common mistake, and it's probably going to happen to you in the future, and you're going to get some code like this. Hey, attempt to apply a non-function. Chances are you're trying to multiply some numbers together without using that shift 8 key. It's something we take for granted when we do math, but very not so in R. Make sure you really specify when you multiply, use that shift 8 star. Okay, as I mentioned here, if you haven't noticed, I've started every line in this script document with a hashtag, the pound symbol. And again, as I mentioned, any writing after a hashtag would be ignored by the console. So let's try stringing along. This is the last example here from this first problem, first set. But let's see if we can try this particular problem. So we're doing 5 times 10 minus 4 divided by 2 plus 3 times 12 minus 4 divided by 4. Sounds like an algebra teacher's best friend here. But again, we could just copy and paste everything here, and just copy and paste, and if everything worked right, it's going to give us the answer, 21, and we could confirm that. This is going to be, let's do what's inside the parentheses, 6. So we have 5 times 6, which is 30. 30 divided by 2 is 15. So this whole expression here is 15. And then on this side here, we have 12 minus 4, which is 8. 8 divided by 4 is 2. 3 times 2 is 6. So 15 plus 6 gets us 21. Smashing. Smashing good time indeed. All right. Section 1.2, using correct syntax for R, tricks and error code. When we say syntax, we're talking about how we're writing the functions here. Okay, so the nice thing is, and as I say here, R can be really frustrating if you're not kind of doing the code right, if you're not writing your script right, which is why it's good practice to make some mistakes and find our mistakes and figure out what went wrong. Okay, first of all, when it comes to syntax, what's kind of nice is that R completely ignores spaces. So if you see in this case, I got 1 plus 2 gives us 3. But it really didn't care if I did the same thing 1 plus 2 and I just had this like enormously useless space in between there. It's not going to care. So it didn't matter. There it is. I know it looks awkward, big old space there, but it just completely ignores it. Whatever, no problem. And as we've seen here, just what I was mentioning here before, without that times, you're going to get in a lot of trouble. I'll say it once, I'll say it again. Whenever we multiply, we need that times, and we're going to see later on when this is a lot of people will forget to use this Shift 8 star key, and it'll get them in trouble. Another thing to watch out for is commas. R has very specific meanings for commas. It usually separates what we call arguments inside a function. So something like the number 1,213,543, if I try to just paste this number into R, even though I'm not doing anything to this number, it's okay. It's going to get mad at me. It's going, hey, there's this unexpected comma in 1, comma. What's this comma doing? It doesn't make sense to me. I don't see a function in here. It's not separating anything. So we just completely ignore the commas. I think we're used to that in calculators anyway, right? We don't need a calculator on this number 1, 2, 3, 1, 3, 5, 4, 3. So don't ever use the commas on these big numbers. And we'll see plenty of big numbers. The nice little trick here I was mentioning is using those up and down arrows to recall previous codes that you have entered into the console. And this way you could edit a line of code without having to rewrite or copy and paste anything. So again, in other words, if I went in here and I went, oh man, I forgot to take my commas out of this number, but it was part of maybe a longer string of code, all I have to do is hit that up button once, and I'm even using the left button. Let's go erase that comma. Let's go erase that comma. Hit enter, and I know nothing really happened because I didn't ask it to do anything to this particular number. Okay, section 1.3. I'm going to get a little crazier on here, but I want to explain our first couple functions that we'll use. So here's some mathematical functions. I'm kind of in math magic land right now. When I say math magic land, I mean just straight up math. We're going to get into stats later. Okay, so if I needed to find the square root of the number, I'm going to use SQRT, parentheses, and then whatever number I'm looking to take the square root of, I'd put it in that parentheses. If I want to exponentiate some number, so b to the x power, I just use that little caret. So 3 to the second, I do 3 comma 2. If I want the absolute value of a number or a function or whatever I want to do inside the parentheses, I use ABS. Exp is actually going to be for E, Euler's number. And that's the number, the natural exponent, and that's 2.718 something something something. Some of you will use it. Some of you might not have remembered this one, but we'll see it. It's E. If we want to round a number, we're going to use the round function, and if I don't put anything after it, it's just going to round it to the nearest whole number, the nearest integer. However, if I put like a comma, if I put round maybe some number, comma, 1, this is now an argument. This is why I was saying these commas have specific meanings here. And this is a function. So it's going to round it in this case to the first decimal place. If I put a round comma 2, it would round it to the second decimal place, etc., etc. There's also what's called the floor function. The floor function is the greatest integer function. It finds the greatest integer. In other words, it rounds not to the nearest number, but to the biggest whole number that contains it. So something like 3.8 would get rounded actually to 3. What's the greatest integer in 3.8? Well, 3. So let's try some. So here's one, square root of 4. This should get us 2 if we did it right. Bam. 3 to the second. So this is exponentiating 3 to the second power. This should get us 3 squared, which should be 9. Bam. So far, so good. This is going to get us 3 to the third power, which should be 3 times 3 times 3. Should be 27 indeed. Good job. How about the absolute value of negative 4? Should be what without me? think I had a freeze there in my recording. I apologize. I'm not sure exactly where I left off. So we were going 3 to the third power. 3 to the third power should be 3 times 3 times 3. And if I paste that in, I get 27. Going back down the list here, how about the absolute value of -4? Do you remember what the absolute value of -4 is? That's right. +4, right? It's the distance from 0. -4 is 4 units away from 0. How about the square root of -4? Square root of -4 is, warning, NaNs produced. That's going to stand for not applicable numbers. Why? Because what's the square root of -4? What times what equals a negative number? It's an imaginary number. R just deals with real numbers. We're not going into math magic land, into complex numbers.
So what's next? So if we didn't like taking the square root of a negative number, we could take the square root of a positive -4 by saying we'll just take the square root of the absolute value of -4. Now let's just kind of diagnose what's going on here in this code as I paste it real quick. So again, I have so here is my open parentheses for the square root sign. Here's the closed parenthesis, and then everything is in here. So what does that mean? Is that order of operation says it's going to do everything inside the parentheses first. Okay. All right. So in other words, it's going to take the square root. No, sorry. It's going to do what's inside the parentheses, which is taking the absolute value of -4, which will get us +4. And then it'll take the square root, so this should give it should get us a nice value of +2, which it does indeed. Right. What are you guys doing? Okay. So if I want to take e to a certain power, the function for e, it can't use e to the first power. If I just go, what's e to the first power? It's probably going to yell at me. It's going to go, what's e? What are you talking about? Hey, I don't know this e. So what we can do instead is use this function x, which is essentially exponentiate the number e to the first power. So if you weren't sure what value e was, well, there it is, 2.7182822, and so on and so on. If you want to take e to the second power, that's no problem. E to the second power should be somewhere in between 4 and 9. Since e is between 2 and 3, e squared should be somewhere between 2 squared, and 3 squared should be somewhere between 4 and 9, probably a little closer to 9. And indeed, it's 7.3898. Rounding numbers is useful. If I want to round a number, like 3.67, if I just hit round, it's going to round this to the nearest whole number, which in this case is 4. But if I want to round to, say, 1 decimal place, well, I can put a comma 1. So this is our first, as I was mentioning, commas have a specific place, and we call this an argument. So this rounding function, it's going to take this first number, that's the value, and then the comma 1 is going to tell it what decimal place to round it to. So for instance, if I wanted to round it to the second decimal place, I can round it, do a comma 2. I'm just totally curious. I've never tried this before. Why not? What would happen if I do -2? 0. What would happen if I go -1? I'm just curious. I think this will actually round it to the tens place. Let's just find out. We want to try this because I've never tried it. Why not turn this to 36? And if this rounds it to the 10 digit, it should round it to 30. 40, it's what I meant, 40. And it did, indeed. Pretty cool. All right, just learned something new. All right, so there's also another function called the floor function. And there's a good times to use the floor function. We'll probably be using it in this class at some point. But what the floor function does is it rounds the number to the greatest integer part. In other words, what's the biggest whole number in here? Well, it should be 3. So it doesn't round this to the nearest number, it rounds it, or what it does is it takes the greatest integer part of the number. So even if I had something like the floor of 3.9999999999999999999, it's going to round that to 3, or it's going to take the greatest integer part of it, which is 3. Unlike if I had the floor function of 4.0001, it's going to take, should be 4, and indeed it is. It's also a step function, if that looks familiar. So for you trig fans out here, we don't have to do any of this in our statistics class, but we have sines, cosines, and tangents too, if you're interested. However, I couldn't figure out how to set them for degrees. There's no obvious argument, so these are only going to be for radians. So I'm going to skip most of these because, as I said, we're not going to have any use for it. But if I wanted to do something like what's the sine of 0, well, I could just go sine of 0 is, for all of you who took trig, you know the sine of 0 is 0. And indeed it is. Unlike the cosine of 0, so cosine of 0 is going to be 1. And indeed it is. Even though we said the number e wasn't stored in R, the number pi, however, is. I just have to spell out pi. So if I ever need pi for anything, well, there it is. So if I want the sine of pi, should be also 0. There's a little bit of rounding there, but it's about as close as you'd reasonably get. Logarithms. Whew, man, we're almost done. Stop it! Kitties? No, meow. Okay, so logarithms. Yes, R can do logarithms. So we have to be a little careful with logarithms because what we're used to when we put in our calculator log is we're used to base 10. We're not going to be, if we just use log in R, it's going to automatically use the natural log. If that means anything to you, hopefully it means something to you. But the natural log is base E, but we can change it. So if I just do log of 2, this is actually going to get me the natural log of 2 with the base e. So what we're saying is essentially e to this power, so that's exp e to the 0.6931472 power should be 2, and indeed it is. So if we want to do something like log 2 base 2, if we want to change the base of a logarithm, this is where we're going to use the argument. We're going to put a comma after the log, and that's going to specify what base we want to do. So if I want to take the log base 2 of 2, so, it should be 1. And why is it 1? What is a logarithm? A logarithm solves an exponent. When we're saying log base 2 of 2, we're going 2 to what power? Actually, hold on, I got the 2 backwards. It's this 2, the base 2 to what power equals this number, 2. So 2 to what power equals 2? 2 to the first, right? So if I wanted to get more complicated, something like, well, we know 2 squared, for instance, is 4. If I take the log base 2 of 4, so I should get 2 because we're saying 2, which is the base, to what power equals 4? Well, 2 to the second power equals 4. If you didn't remember what a logarithm is, we'll get there eventually again. So something like log 32, log base 2 of 32, we'd write like this. So hey, 2 to what power is going to give us 32? Well, log of 32, comma 2, well, 2 to the 5th power equals 32. Trying one of these here. So this is a log of x3. That's log of e to the 3rd power, and this is base e. This might sound a little complicated at this point, and I'm probably making it more complicated than it needs to be right now. But the answer is 3, because we're saying e to what power equals e to the 3rd. Well, e to the 3rd equals e to the 3rd, of course. Of course, right. Smashing. Who didn't know that? Everybody knew that, right? Phew, it's so easy, even a PhD candidate in astrophysics can do it half the time. Okay, so let's recap what we've learned this half hour. Number one, R uses the order of operations, PEMDAS, when performing calculations. The big one is don't forget to use the star, the shift 8 key anytime you multiply numbers together. If you get an error, try your best to interpret the error code. And functions in R always use parentheses. Many functions, like logarithm functions, have arguments, which in this case will allow you to determine the base of the logarithm. We're going to start seeing a lot of these arguments as we go along. And why, it might seem complicated, but it's just things like, hey, let's make a histogram, but let's give it this title. Let's make it this color. Let's put this label on the x-axis. Let's put this label on the y-axis. That's where we're all going for right now. Okay, so what I'm going to do is you have a homework assignment, and it was you should have downloaded it, and it should say R Lesson 1 homework. So let's open that up. And it looks a little bit like this. I have this as a Word document. I saved it as a PDF too. If you open up the Word documents and if you get funny stuff here, you might want to use the PDF file. And here is the nature of this homework assignment. And I'll do 1 or 2 problems with you. I'll pick a random one here. So we're going to use R to calculate the correct answer. We're going to copy and paste the code and solutions that we used. So let's pick a good one here. I'm going to pick on this one, number 4. So I'm going to use R to solve this mathematic problem, and I want to, and please don't do it by hand. Let's just put it in exactly the way it is in R. So I want to solve this problem. 6 times 5 minus 0.6 plus 2/3. So I'm going to go into R, and here's what I'm going to do. It was 6 times R. So the trick here was I need to use my shift 8. I had some parentheses. Let me go back and look at the problem again. 6 times 5 minus 0.6. So it was 5 minus 0.6. And notice I didn't need that 0.6. It doesn't matter. Plus 2/3. And it'll spit out the answer. So here's what I'd like you to do is put in the problem exactly the way it's written. Don't simplify. Don't try to reduce anything. Don't try to go crazy. And just copy and paste what you just did. And just under this little space where I give you some space, copy it and paste that in. One thing I wouldn't mind you doing is, number one, maybe just, we don't need to put it in the middle, but sometimes I like to change the font. A good font to use is Courier. It just kind of looks like the font that we have already in R. And it just will kind of just, this is what I'm looking for. So again, the problem, we're using R as a calculator to calculate the correct answer. And notice how I just put this in word for word, and then I got my answer there. That's my answer, 23.06. I'll try this one. This looks kind of crazy. 3 log base 4 of this crazy number. So The 3 means 3 times. The log is base 4, and then we got this crazy number that I'm just going to copy because we're going to need that number anyway. So it was 3 times shift log, and of that number, which I just copied and pasted in, and comma, the base was 4. That's going to be my answer. Wow. Did I even know it had such a pretty answer? Maybe I did. So it did have a pretty answer this time. Exactly 27. And I say that because usually logarithms give us nasty answers. So I just copied and pasted that right in. For some reason it was bold, so I'll unbold that, and I'm going to change the font to Courier just to make it look a little nicer. Last set of problems, 14 through 17, ask you to say, the problem says this: each code has an error, identify the errors and fix it, and then find the actual solution we were going for. So for instance, number 1, we got 543,231 plus 32,238. So here's how I'd like you guys to do these. Just take this straight up, copy this, paste it into R the way it is, and hit enter and see what error code comes up. So in this case, it has the unexpected commas. Uh-oh, what did I do wrong? I'm using commas on these numbers, and R does not like commas. So just clean it up, fix it. So you're, and then again, copy, paste, find the actual answer. So I'll do that first. And then it asks me to identify the error, and I can just identify it. I'll call this. It gave us the error code, but I'm just going to say improper use of commas. And again, maybe I'll just change my font to make it look just a little different. That's your first lesson, and we'll talk about when the due date is. I hope this video was helpful, and it's online and it's for you whenever you want. Thank you.